Okay, so my name is John Arthorne, and I'm going to talk to you about a project I worked on over the past year at Shopify, where we use GitHub to do a better job at keeping track and automating our software infrastructure. So just to give you a rough idea of the flow of this, I'm going to give you a little bit of background on the company and our tech stack really quickly, just to set the baseline. You can see what we're talking about. Describe the problem that we were facing, and then go through the implementation of what we built to address it. So Shopify, for those who aren't familiar, is a build software as a service for commerce. So anyone who wants to have an online store or a physical store and they want software for that, we provide hosted software. We have about just over 500,000 merchants on the platform, and those merchants do an average of 65 million a day in GMV of sales. So it's fairly small compared to some of the bigger players out there, but non-trivial size. Number of employees, we have about 2,000 employees in the company, over 4 or 5 offices. To give you just a sense of the scale of our platform itself, so our core backend system has a throughput of about, between like 40 and 80K RPS, so requests per second come into our HTTP server. So, depending on where you're from, that's either really small or really big or somewhere in between. But just to give you an idea of where we're at. So Shopify started out actually very similar to GitHub, around the same time as GitHub, as a Rails application, and is still today largely based on one very large-scale Rails monolith, which is the core backend platform. However, over the years, we've ended up building more and more pieces surrounding this monolith. So we've, over time, built a number of other Ruby and Rails applications for a variety of different purposes, from merchant-facing critical things all the way down to internal tools and experiments. So lots of different Rails applications that we use for many different things. We also have a fairly large data stack for doing sort of big data analysis and processing, which is mostly Python-based. So we have a collection of applications that are used in the data space that are using Python. We also have a fair number of systems that use Golang. So in particular, systems where concurrency or performance are super important concerns. We use Go for that over, Python and Rails Ruby are very expressive languages, but they're not always the fastest languages. So we have some of that in the mix. As far as data stores, so we have our main sort of relational data store backend uses MySQL, and with Redis for like ephemeral key value stores. We have a number of other different storage systems as well. All or most of this, actually everything either is or very soon will be containerized applications using Docker and orchestrated with Kubernetes and running either we have our own physical data centers, or we also use a couple of different third-party data centers where we have a number of these applications running. So the important detail here for the purpose of this talk is that we started out with this one monolithic Rails application, and we've discovered over time that we were in this world where we had a very large number of systems written in a variety of different languages running in various different places. And that led to some problems that we had to solve that I'm going to talk about. So the main problem we were facing, as I was saying, is that we had these sort of practices within the company that were evolved around maintaining this large monolith application. And we were, got to the point where we're doing quite a good job of keeping that monolith very well maintained and healthy. But then all of this other stuff that had grown up around it had very inconsistent levels of infrastructure supporting it. So we found that, our sort of way of working, which was oriented towards a very small number of applications, just wasn't scaling when we found ourselves in a company where we had a couple thousand employees and hundreds of different systems floating around. So we knew we needed to do better at this. And in particular, one of the areas where we were suffering was in what I call service infrastructure. So if you think about the analogy of a production system like a race car, you might think superficially that it's a race car and its driver that wins races, but in reality, it's actually a huge supporting cast around that car. There's designers and engineers and pit crews, and there's a large cast of supporting characters around that car, and that enables it to do really well and win races. And it's very similar with production applications. So, you can just write the code and throw it over the wall into production, and it might do okay, it may or may not. But if you really want to make the best possible production system, you need to care about that big cast of supporting characters around the production system. So, and in the space of, when I'm talking about a production web applications or systems running in a data center, some of the concerns I mean here are all the different various forms of automation. So CI pipeline, deployment automation, the automation that developers use to set up their local workstations for development. There's a large number of different applications that you typically need for monitoring, for getting telemetry and metrics out of the system, tracking of the logs, tracking of bugs. So there's a large number of different tools that you need in order to do a really good job at maintaining a production system. And again, all of that is well and good if you only had like 1 or 2 production systems, but if you find yourself, as we did, with over 300 production systems, and you have all of these concerns to worry about, it becomes a really hard problem to keep track of, like, do we have all the right infrastructure in place for all of these different systems or not, and what do we need to do to get better? And we discovered that this anti-pattern was being developed where whenever we need to make a major change to our infrastructure or to the systems, we found ourselves, someone would invariably create a Google Sheet and start to pull together a list of all the systems that we would need to apply some particular change to. So in this particular case, it was finding the list of apps that are using a Rails version that's about to become obsolete and unsupported, which means we either need to upgrade them or shut them down. So in order to do this, we had to gather all this information from various places, go to GitHub, find all the source code, find where the runtimes are, find who to talk to figure out what we need to do with this. So we kind of had to manually pull together all this information to make these decisions or make these changes across a set of software, a set of different systems. And we found we ended up doing this more and more, and this was clearly not an approach that was going to scale. And every time we had to do this, it took days out of developers' time to pull this information and make all these decisions. So we started a project to build a system to automate this management and tracking of all of our software infrastructure. So, and we had 3 main goals in building this project. So the first was, which might seem weird to some of you depending on your company, was actually establishing ownership for production systems. So we had a culture where it was, if you saw something wrong, you should just go in and fix it, and we didn't actually have clearly defined like people or teams matched to any different system. So we decided this was something that we needed to move towards a more concrete model of who owns these systems and what that means. Second, we wanted to be able to measure how well are we doing, for all these different systems, and are we getting better or worse, and what do we, how much work do we have to do to get better at this? And third, all of these manual repetitive tasks for setting up monitoring or moving your logs to Splunk, for 1 or 2 services, it's not a big problem, but when you have dozens and dozens of services, all of these kind of infrastructure concerns become like it just doesn't scale, right? You have to do all this manual toil work to integrate all these different things all the time. And we felt by having all the information pulled together, we might be able to automate some of these things. So we built this, so I'm gonna go through these different goals. So the first one, as I mentioned, so Shopify, as a small startup, had this culture of, like, one of the company mottos is act like an owner, which means if you see something that needs to be doing, pretend, if I was the owner of this company, what would I do? Okay, do that. Like, that was the solution to most things, was do what you would do if this was your company and you were responsible for its success. And that was an approach that really worked well in a very small company, but when you have 600 people being told to act like an owner, you can get that bystander effect, right, where everyone feels that they're able to reach in and do it, but who is the one who's actually going to go and make some change or do something for any system. So there's a number of different cases where not having these clearly defined owners was clearly becoming painful for us. So one example is when we have an incident, so something's down, and we urgently need to find out more information about, what is this thing? Does it matter that it's down? Like who can help us bring it back up again? So that's an obvious case where knowing, someone to reach out to talk to is really valuable. Another case is, you want to make these longer-term decisions about a system. It's all well and good that I can reach in and open a PR against some other app, and it gets accepted and it's all good. But if I want to make these long-term decisions, I really want to have a conversation with someone who knows the background of that service and can say, like, here's this thing I want to do with it. Does that make sense for the goals of this application? Should we build some new thing that replaces both of them or whatever? You really need someone to talk to have those decisions about making long-term decisions about the different systems you're running. So we decided what we really need was defining ownership for things and moving more towards a concrete notion of like this system is owned by this team. However, we really wanted to avoid the other end of the spectrum of this, if you see in very large companies and in governments where you have a very authoritarian notion of like who owns what, where you can't even access the source code for other things, and it's very bureaucratic and very slow, and we knew very much we didn't want that. We wanted to have the, as GitHub users, you're all familiar with the power of being able to reach in and open a pull request against things and have the flexibility to do that when you need to. We wanted to make sure we kept that, but giving people the level of autonomy, but still having a clearly defined notion of ownership for things. So this, over a year ago, so we decided we need to do something about this, and we said, what's the simplest possible thing we could do as a prototype of this to flesh out the ideas and the tools? So we said, okay, let's create a file in every repo which has it's a YAML file with keys and values, and one of the values is who is the team that owns this, the person or the team, GitHub team that owns this application. So if we were starting this today, we would probably use the code owners file that has been introduced since we started on this. Our version of, you can think of what we have as a very simplified version of the code owners file that is available in GitHub today, but just very simple. It's just this team owns this repo, nothing fancy. And it turned out that we actually only intended this as a prototype, like minimal viable solution to this, but it actually worked really well. So one of the cool advantages is if you have a system where you need to change owner, teams get reorged, or someone leaves the company, or someone joins, you can just open a pull request and say, hey, I think we should move ownership of this to that team. What do you think? Tag the previous owner for review on that change, get it approved, and ship it. This was a really natural thing for developers in our company to do. That's how they make all important decisions, is in the context of a pull request and a discussion like that. So it was a solution that worked really well for us, and we still use it today. And now that you have the code owners file in GitHub, that's something that you could all use as well to not only track ownership, but use pull requests as the mechanism for making these organizational changes. It's kind of neat. So the second goal we had was measuring, like how well are we doing? Are we getting better or worse at like all this infrastructure that we need around these applications? If you're a team that has a large number of applications, you probably want to know, like, where should I spend my time? Which of my services are doing really well and which ones need work, so I can figure out where to spend my time. And we also decided we needed to, we have this core monolith that's super important, has millions of dollars GMV going through it, and then we have these little toy internal tools where if it goes down, it's not a big deal. A one-size-fits-all solution, I have these two Rails apps with vastly different requirements. It doesn't make sense to have the same infrastructure around these two different apps. So we knew we needed to sort of differentiate between these different systems in some way. So what we did was we built this application, another Rails application, which we love building, and we connected to the GitHub APIs, pulled in all of the, everything at Shopify that's important is in a GitHub repo somewhere. So we pulled in all the GitHub repos in the organization, all the GitHub users and teams, and that was the core model behind the system. And then we reached out to all the different runtimes we have So we use Heroku and AWS and some other systems, and we can call the APIs on those and pull in the list of our runtimes, call out to all of our different third-party monitoring tools, collect the list of things that are being monitored, et cetera, and pull them all together. So the very first benefit of this was we could create this dashboard for every production system. There's this page now where you can search for your system and pull up this page, and you can see, description of what it is, who owns it, what is the public URL, where's the source code, where are the Splunk logs, where's the PagerDuty team that's on call for this thing. So you sort of just have all this information pulled together in one place. Was a huge benefit for us, where we no longer had to jump around between all these different places to find out information. We can just go to this one place and access all this information we needed. You can see we also pulled in a number of different metrics. So from GitHub, we've taken commit stats and issue data and captured that as well, so we can kind of see over time a rough idea of the sort of trajectory of this system. Is it trending towards is the commit count trending towards 0, or is it going up? Is it stable? It just gives you a rough sense of sort of the health of this system. So okay, so we've got all this information. Like, is that good? Like, is this system got everything that it needs? So we know what it has. Does it need to have more, or does it have too much in place? So we decided we need to differentiate between the systems and create these different tiers of applications, where as you go up in tiers, there's higher and higher expectations of what you need for this system. We wanted to do this in a fairly lightweight way. We didn't want to have a lot of process around this, so we tried to keep it as simple as possible. So what we came up with is this 4-tier system, where at the very bottom we have tier 4 is experiments, and we have a culture in the company of highly encouraging people to do experiments. If you want to spin up a new system to try something out, go ahead. No permission needed. Just do whatever you want. And we want to keep the bar very, very low for that. We don't want to impose a lot of requirements on a system like that, because the whole point is moving fast and trying things out. So for experimental systems, we only have 2 requirements. One, that there be an owner, and that it resolves security issues. So very, very low bar. And then as we go up, so the next tier of applications are, for the most part, internal tools. So they're things that are useful within the company, but not super critical. For these ones, what we want to make sure is we have all the infrastructure in place so that a team of people can work on it. So most importantly, it has automation for setting up my local dev environment. It has the CI in place. It has very basic monitoring in place. So it's something that anyone in the company can come in. They can do a clone of this. They can run the script to start it up. They can try it out, and they can submit a change and run it through the CI. So it makes sure that this is an app that anyone in the company can access, work on, and contribute a change to, and be able to do that very easily. And then as we go up, there's more and more requirements on what we need to have in place. So tier 2 are systems that are very important, where if it's down, either there's some minor impact to our customers, or there's a major impact internally, as a large number of people in the company can't get the work done because they need this system to be up. So for this level, we have a number of other requirements that we add on. The most important ones are that there be someone on call for it, so the developer team that is building this has an on-call rotation for it, and that there's monitoring in place that will alert when it's down and will notify that team. And a number of other fairly minor requirements compared to that. And then at the very top, we have a very small number of systems like our core monolith that are tier 1. These are things that are super critical to the company. If it goes down, there's either a large financial or reputational impact, and we absolutely need these to be our highest quality, most resilient systems. And so we have a number of other requirements on the top tier systems. The biggest one is that it be resilient to any single data center going down. So any system at tier 1 should be able to withstand any one data center going down, and we should be able to withstand that through resiliency and redundancy. Okay, so now that we know the list of all of our things, we know what tier it's in, now we can create this scorecard view where we can show you, for an individual or a team, you can get this list of here's all my things, here's all the requirements for the system of that kind, and how are you doing? So you can quickly go to this page and go, okay, some of these things look pretty good, but this thing at the top has got a bunch of things missing, I'm gonna go in and fix that. So it gives teams the information they need to make decisions about what they need to be working on for the infrastructure of their applications. So this is a really useful tool. The second thing we actually added just over this summer as an experiment. So we thought, let's add a little bit of gamification into this. This works really well in video games. Let's try this out. So we created a leaderboard view, and literally all we did was we created this view. It ranked every team in the company, how many systems and how many things are missing, and gave them this percentage score. And we just sent an email saying, like, here we created this view. Like, hats off to these group of people at the top that did a great job. Here you can go and see how you're doing. And that's all we did. We didn't do any enforcement or anything beyond that. Just doing that one thing had the single biggest impact on the quality of all of our systems. So within a month of just creating this view and letting people know it was there, tons of developers were just like, if they saw yellow or red, they were just like, it just made them anxious, and they were like, I gotta compete against the other team over there, and I want to do really well. This was like an intrinsic motivator for a lot of developers to up their game on their systems and do a lot better job without any further prodding, just by having this view available. So that was really interesting discovery for us. So once we've got, we're measuring how well we're doing, the next step, as I mentioned at the beginning, was now we've got all this information, we've got all this connections in place between our different systems. Can we build some automation to make it as easy as possible to maintain systems and take away some of the manual toil involved? So this is where it gets really, really fun for developers, where they can see this not just as a tool that's telling them what they're doing wrong, but it's a tool that's helping them figure out how to fix and how to improve their systems. So the first thing we can do with ServiceDB is we can open GitHub Issues for anything that is wrong with that system. So we'll automatically open an issue that says, here's the thing you're missing, here's a link to some documentation to help you figure out what to do about it. So it gives developers all the information they need to make a change to their system. And even more valuably, robots opening issues against you doesn't sound all that cool, but robots that automatically close issues when the underlying problem is fixed is really valuable, right? So this bot will now monitor this system to make sure, so this case it's missing uptime monitoring. So once we detect that uptime monitoring is in place for this system, we'll automatically go and close the issue for you. So we can make sure that, we do that bookkeeping and make sure that, we don't leave a mess lying around in your issue tracker for things that are no longer a problem. So the next thing we were able to do by having all this information together was what we call fighting against the email bots. So we have a lot of different third-party services we use. Many of them send alerts to us in the form of emails to say either you've exceeded a quota, or this thing is wrong, or we're doing a maintenance, FYI. And once we're at the scale of hundreds of systems, they just became noise. Like, nobody was reading these emails anymore because there were just too many of them. So what we did was we instead of having these emails go to a person, we sent all these emails to ServiceDB. And what it does is it parses all the emails that come in. It assesses what needs to be done about this. Is this just like an FYI thing, I can just throw it away? Or is this something that requires action by a team? And if it does, what we do is we take the body of that, essentially, we turn it into a GitHub issue. We know what repo it's against. We can open an issue. We can tag that team because we know what team owns it. And that way we've sent this information that was sort of blasted out to all of our admins. We've now filtered all this information to the team that actually needs to know that problem so they can fix it. So this was really a huge benefit in reducing the noise of these sort of email-based alerts we were getting. So next thing we built using this infrastructure was automating some of these repetitive tasks. So a simple one here is, this is a system that should have uptime monitoring, but it doesn't. But hey, we know what the public URL is. We have access to so we use a third-party tool called Pingdom for doing uptime monitoring, which has APIs. We could set that up for you. So just say, yes, I want this, click the fix button, and we automatically set up the monitoring for that system for you. So there's a number of other places where we built automation like this that just took away a lot of manual pain. Another big one was wiring all of our alerts into PagerDuty so that when this alert fires, the appropriate team in PagerDuty was alerted. Setting those things up is a real pain. I'm sure if any of you have done it, you know what I'm talking about. That you have to sort of go between these different tools and copy an authentication key here and there. There's many different ways to do it, lots of different ways you can do it wrong. It's just something that you don't want to have to bother to do. So this was another thing where we were able to use automation to say, well, we know what your monitoring is, we know what the PagerDuty team is for this particular system, we can configure all those alert connections for you. And that was a really valuable benefit of having all this information together. So where it gets really fun is we started to do automatic code authoring for simple changes for these systems. So this started out with a lot of our systems are using Kubernetes, which have these configuration files that have various information about the infrastructure for this system. We're able to open a pull request whenever, let's say we need you to change to a different, like we need some configuration change to be made across a whole fleet of systems. We can automatically open pull requests to do that for you. And that was really valuable just to save people from having to manually apply updates to things and so many opportunities to get things wrong. The other area that we've been working on over the summer is doing automatic software updates for your dependencies. So this sounds a little bit like what was announced yesterday actually with the dependency graph and the security alerts, where we can, we know that you're using this library. If you want to update this library or if there's a strong reason to update this library, we can open a pull request for you automatically to make that change, and then CI will run, and you can look at that, and you might be able to just merge it, and you'll be okay. So this just took away a lot of manual toil that developer teams across the company were having to do to maintain their systems. So you can kind of see we turned this on in June, and this is the contribution graph for the ServiceDB GitHub account, and you can see became much more active. It's now one of our more productive developers in the company because it's doing a lot more of these repetitive tasks for us. So I'm going to go a little bit into more detail on the implementation quickly. So the system is, as I mentioned at the beginning, it's a Rails application, and we connect out to the APIs of these different systems. So we use the GitHub API to access some of the really core models of the repos, users, and teams. And the issues that are open against these repos. We also connect to the different runtimes, pull that information in, and connect to all the different third-party tools and pull that information into our database. We ran into pretty severe rate limiting problems with GitHub and most of these other systems. So the general approach we've taken here is that ServiceDB will sort of copy all this information in periodically into our database, and then we don't actually call out to GitHub or to these third-party systems during routine usage of the tool or when we're running our checks against our systems. We sort of rely on our internal database. We just reach out when we need to access new information. GitHub, of course, has webhooks, which are extremely valuable so that we can really cut down on the number of times we have to go and ask for information. They'll tell us when things have changed that we care about, and we can update our model sort of incrementally. So that was really valuable for us. Some of these systems have webhooks, some of them don't. So as far as the user interface for the developer team, so we have a web application. You've seen some of the screenshots of the different parts of that. We also have a Slack bot that connects into this as well that gives you a number of different tools that are available from within Slack, which is really useful. So a couple of the other key concepts here in the system. So we have these classes called checks, which are each check it's a piece of logic that checks whether this service satisfies this requirement, like it has an owner, it has uptime monitoring, etc. One of the neat ones that was really valuable was this. We have this SSL check, and what it checks is this system using HTTPS protocol, and is the certificate for that valid and not near expiry? So that's a really valuable check that we're able to run against all the systems and let you know. And then we have these other things that are also sources of information that we are pulling in, like the emails from the third-party providers. And we also have Slack commands that people can run to say, I want to sort of generate an event to say everyone using every tier 4 app in this Kubernetes cluster needs to do X, and we can generate events for that. So events in the middle are, so we have all these things that are sources of sort of alerting on our infrastructure that letting us know that something is wrong. The event has the logic to decide what to do about that. So this is something we spend a lot of time refining because it can very quickly get very noisy if you have systems that are automatically opening issues against you, automatically pinging you. We really want to make sure that we're only sending an alert to a team when it's important, and that we're using a channel that's appropriate depending on the severity. So if this is something that's high urgency, we'll use the Slack announcement because that's the most reliable way to access our dev teams quickly. If it's something that's important but not urgent, like it's something I need you to do soon but not right now, GitHub Issues are the best way to do that, where they can take action on that, whenever they can fit it into their development cycle. And of course, ideal case is we can open a pull request for those situations and and give you a first cut at what the fix might look like. So we have these various channels, and we'll pick the one that's most appropriate depending on the check or the different alert that's coming in. And the events are the bits of logic that make those decisions. So getting a little bit into the library upgrades, which is similar to what was announced yesterday. So this is another thing that can very quickly get noisy, right? So if you have a lot of systems and each of them has dozens or hundreds of dependencies, we don't want to be opening, even if it's a pull request, we don't want to be opening them every time every single third-party dependency you use has a new version available, because it's just too noisy. Like on most systems, that would mean all you're doing all day is upgrading all these little libraries. So what we wanted to do is make sure that we're only opening these pull requests when it's really valuable to do so. So we have 3 different sources for, that tell us when it's important to open these pull requests. So the first one, most obvious one, as mentioned yesterday, when there's a security vulnerability advisory against a particular library, then in those cases it's very urgent that we make sure that every system that's using that version of that library gets upgraded as soon as possible. So that's the first one that we implemented, that we open pull requests immediately as soon as an advisory comes out with the upgrade of the library in question. Another one that we built was, we have this notion of being able to deprecate a particular library or library version across the company. And this is something that we use we have a number of internal libraries that are used by many different systems, and we might decide we don't want to maintain this anymore, or there's a compelling reason why we need you to upgrade it. Or it could be a third-party library where we have an important company reason to say you should not ever use this version of this library anymore, please upgrade it. So we have essentially a company blacklist of library versions where if you're using that, we'll automatically open a pull request to get you to fix it. The third category is we have this notion of important libraries. So this is for Rails applications. We've identified about a dozen libraries that are just really critical to keep updated. Like these are libraries where if you don't update it, chances are you're going to be very quickly running to a security vulnerability, or you're going to be just creating a lot of tech debt, because this is a library that you are going to have to upgrade sooner rather than later. So we might as well open a PR for it. So this is where we're trying to find the balance of not blasting you with PRs for every little tiny third-party library you're using, just making sure we open these when it's really valuable. So we have this notion of these libraries that you should always keep up to date. That's fairly small. So all of these are the 3 different sources for the auto generation of pull requests for updating those libraries. So some of the future directions we're looking at, we've got lots of different ideas. We definitely like to automate more infrastructure work. So any kind of automatic work that people need to do to run their systems, we're always on the lookout for those so that we can add more sort of one-click automation to set up or update or whatever your infrastructure. We'd like to do library upgrades for other languages. So today we only support Rails, and we've got some support in place for Node, but we'd like to be able to do that for Golang and Python as well. So that's something that we're hoping to do, or maybe we'll be able to take advantage of some of the capabilities that GitHub's introducing for that through their dependency graph. Another area that we want to work on is defining SLOs, service level objectives. So this is a concept that's really popular in site reliability engineering, where you define the metrics that are really important from a user's point of view for your system, and then keep track of how you're doing on that metric and whether you need to do better or not. So it's kind of taking your sea of metric information and highlighting the ones that are really, really important for each system. And we think the database we build is a great place to define those and track how you're doing. Another area is we have a lot of, whenever we have any kind of service disruption, we have a postmortem and we come up with a set of actions that need to be done. These are invariably opened as GitHub issues sort of all over the place in the company, depending on where the problem is. And we have no sort of single way to keep track of all these action items and how are we doing at making sure that we do the follow-up. Whenever we have a failure, we want to make sure that we learn from it and we get better. So we want to be able to track all those actions in this common database so we can do that. So the key takeaways from us out of all this that I think you should think about, like, is this applicable to me, or how can I do something similar in my company? So the notion of ownership was something that was a big cultural change for us, like moving away from the startup mentality of everyone just reaches in and does what they need to do to get things done, to a model where you can do that, but there's also someone defined who's the sort of steward or owner for the system. The other area is, when you're thinking about all this infrastructure, it's always a matter of trade-offs. So the right answer is not always add more and more monitoring, add more and more systems. You want to make sure that you're only doing these things when there's a really strong reason to do so that you're not just adding extra toil for the developer teams for nothing. So trying to decide, like, what is the bar that we need to meet and make sure it's no higher than it needs to be, so that we're not creating unnecessary work for people. And the other key takeaway for us was getting really sensitive to areas where there's manual toil work and maintaining systems. So when you have one or two applications, manual toil is not so bad, but when you have dozens or hundreds, this toil work and spread across a large engineering organization really adds up. So we become hypersensitive now to, hey, like, this is like, why are we opening an issue telling people to manually do X? Like, can we build some automation to do that for them? And that's something that we find ourselves paying a lot more attention to now. So that's about it for my talk. So I'm not going to be able to take any more questions right now, but feel free to catch up to me later today, or I'll be at the back of the room if you have more questions, or you can access me on social media. So thank you very much for your attention, and enjoy the rest of the conference.